Okay, so I brought all of exams 1 and exams 2, so we can go through those. I'll show you the different types of questions that you'll have. But in short, you're going to have half projectile motion and half vector questions. It'll look a lot like the first 10 or 12 questions on those exams when they're, on a single exam. But as I said in class, that sometimes you have questions from exam 1 and the questions from exam 3. Sometimes I get vectors in exam 1. I haven't been lately. I've sort of been shifting the way I do the exams, but sometimes you get those in exam 1. So here I'm looking at exams 1, but first of all, I guess, are there specific questions that y'all have? Yeah, Jadacia.
I have a question about number 17 and 20.
In fall 20?
Oh,
Fall 21, okay, well that's this one right here. This one? Yeah. You have a specific question, or you want me to work through it?
um,
Yeah, you're going to have a question like this on the exam, on the quiz. I'm pretty sure there's one a lot like this, where you have two vectors and you have to find the magnitude of the sum of the vectors. You have to find the sum of the two vectors. 3 steps. You haven't been in lab today, those of you who are in lab. You first find the x and y components of the vectors. Then you add the like x components, add the like y components, ax plus bx, ay plus by, and then you find the magnitude and the direction of the resultant vector. All right, 3 steps. X and y components, add x and y components, find the magnitude and direction. Here I'm just looking for the magnitude. So first I'll find ax and bx, or excuse me, ax, ax bx, ay by. Ax is 12 cosine 30. That's equal to 10.4. Ay is going to be 12 sine of 30. That's equal to 6. Bx is 0, and by is negative 8. The reason I knew that bx is 0 is because b is 8 units along the y-axis. Yeah?
What's the, what's for the AX and the AY? What is the degree? What is the
Ah,
angle x 30?
you know what? I skipped a step. I usually draw the picture, and since I didn't do that, I missed that. So yeah, let's go back and just take a deep breath, and I'll draw a picture. I have A as 12 units at 30 degrees below the x-axis. So yeah, you're right. Now that I draw that, I see that AY should be negative. So this should be negative 6. Important to draw a picture. I find that you just make mistakes if you don't draw pictures. And then B is 8 units along the negative y-axis. That should be shorter, actually, if I'm drawing it to scale. Sorry, I was trying to rush. All right, so that's what my vector should look like. The resultant vector is going to be right there. Okay? So, yeah, so now that I have the signs right, I have AX is 10.4, AY is negative 6, BX is 0, BY is 8. Brianna? Ah, yes. Thank you. Y'all can take it out of my paycheck. Is that what you were going to ask too, Bryce?
Yeah.
Okay. Let's take it out of my paycheck. You know they do that. Like when like y'all ever wait tables? Do y'all wait tables? Anybody? You wait tables? Where do you wait tables?
Rockbretta, the restaurant
Oh yeah. So when I used to wait tables, if you drop plates, they take it out of your pay. They do that too?
No, but if like break something wrong and it's our fault, and then
Yeah. Anyway, they do that to us too. When we make mistakes, they take it out of our pay. 12 units at 30 degrees below the negative x-axis, so right there, and then 8 units along the negative y-axis, like that. So the resultant vector will be like that. Okay? So that also means that AX is negative as well. Ooh, that was a little tricky, wasn't it? Not tricky, it's just you want to make sure that your vectors are drawn in the right quadrant. So here A has both negative x and y components. Now I'm going to add, in the second step, I add the x and y components, so I get negative 10.4 right here. Here I get negative 2. That's just 6 minus 8. AY plus BY, which is negative 2. Then these give me the x and y components of my new vector, Rx and Ry. So I can draw that vector. Well, I already have drawn it actually. It has an x component of 10.4 or minus 10.4 and a y component of negative 2. Did I not draw that to scale? Yeah. Oh, man, I'm making all sorts of mistakes today. I'm really sorry. Yeah, so it should be negative 6 minus 8, so it'd be minus 14. But you see, I realized that when I drew the picture because it just wasn't looking right. The picture that I drew, because the picture that I drew has a much bigger y component. So I would have caught that, Jadesi, I'm pretty sure, if you hadn't. I think I would have caught it because I'd drawn that picture. The picture is going to be really important for you. So now I have the x and y components, minus 10.4, minus 14. Those do jive with the picture that I've drawn, so I think they're right. Now if I want to find the magnitude of r, it's going to be equal to the square root of 10.4 squared plus 14 squared. And that's going to be, what is that, 17? No, that's not 17. What is it?
It's 17,
Okay, so 17 is the answer. The negative 14? Yeah. So people had some issues with this in lab this morning. They were using the negative, like they would do in their calculation, they would do the square root of negative 4 squared plus 2 squared, for example. And in their calculator, that was giving them, making this into a number that's negative 16. But negative 4 squared is not negative 16. Negative 4 squared is positive 16. So depending on your calculator, it might not follow the order of operations correctly. Let me point out what that calculator was doing this morning. I forget who that was. But when they put this in, it was doing the 4 squared first, and then it was applying the negative, which is not what you intended, right? You intended for it to be negative 4 times negative 4, which is positive 16. But here it was doing the square first and then applying the negative, which is not really correct. So either you have to be really careful with your parentheses. I think just leave that negative off because you know it's a negative number squared, so it's going to be positive. Okay? You have a question?
My teacher used to say, remember the calculator is smarter than you. You're the one making the mistake.
Right, yeah. Well, yeah. All right. Jadesi, does that help? There will be a question like that. I'm 99% certain that there's going to be one, I'm pretty sure. All right, there will also be graphical questions. In fact, you know, your problem's going to look a lot like this. You're going to need to find the x component. Remember, x component is always the magnitude of the vector times the cosine of the angle. There'll probably be a question like this or something similar to it where I'm asking you about the relationship between the different vectors. There was a whole series of those in the concept test on vectors. I haven't posted that yet, have I? I will post that on. Let me make a note to myself to post the concept test. I'll do it when I go back to my office. All right. There will be a graphical like this one right here. Let's look at this one. Somebody asked me about this earlier. Vector A is 20 degrees from the positive x-axis, and vector B is 170 degrees from the positive x-axis. Which of these vectors is the possible sum? So you want to sketch out the vectors. I have vector A is 20 degrees from the positive x-axis. That's vector A. And then vector B is 170 degrees from the positive x-axis. So vector B is over here. And now I want to know which of these vectors, these 5 vectors that I've drawn, which of those is a possible sum of A plus B. Notice that there are options here that have 2, or maybe all of them are possible. It depends on the magnitude of A and B. So for example, if A is really small and B is really big, then say this is the vector B and A looks like that, then I'm going to get a resultant that's over here. Right? I'm going to get a resultant of those 2 vectors that's closer to the A vector. Or if the opposite is true, if B is really big and A is really small, then the resultant is going to be on the other side. So I can get different resultant vectors depending on how big A or B is, those 2 vectors. So, however, the sum of those 2 vectors has to lie in between those two vectors. So it can't be that, can't be that, and can't be that, because all those lie outside of that space in between those two vectors. So it has to either be A or B. So B is the right answer here. That's a lot of A's and B's, isn't it? The answer is B. Yeah, Jadesia.
So what is the difference between that problem and past start tail to tail?
Ah, yeah, so this one is asking for a range of answers, but let's look at one of those tail to tip problems. They are a little bit different, actually, but on this problem, just remember that if I have two vectors like this, then the solution or the sum of those two vectors has to be in between. Okay? I like to think about it in terms of force vectors, where if I have, say, a guy up here pulling on a rope and a guy over here pulling on a rope, then the resultant of those two forces is going to be in that direction, right? Like if they have a cow or something attached to the ends of that rope, that they're going to pull that cow in that direction. Have you ever done that where you had a cow to the rope? Yeah? No. Okay. But let's do one of those questions like you were asking that. You have a question? Number 19? No. Hold on just a second, though. I don't see one of those on this test, so we'll go to another test and look at those. Let's look at 19. We had a whole series of questions that were similar to this about, if these two are parallel and in the same direction, or if they're perpendicular, or if they're, various orientations of the vectors. In this case, we're asking the two vectors add up to equal to C, and also the magnitudes of the two vectors add up in that way. The sum of the squares equals the square of the resultant C. This should peak in your mind something. What does it look like? That A squared plus B squared equals C squared? Pythagorean theorem, which only applies to what type of triangles? Right triangles. So that means that my two vectors A and B are like this, and the vector C is like that. That Pythagorean theorem only applies to right triangles. Look back at that concept test. You'll see similar questions in the past exams for different variations of that question. There aren't that many different variations. But let's look at one of those. Daisy was asking about with the like this one. That's the one you mean, right? So there are a bunch of these on the past exams. You might have one of these. I don't remember. I'm pretty sure I put one on it. Your quiz looks a lot like these exams, sort of same number of questions from each topic. So here I want to know what is A minus B. So first I draw A. I'll just draw it right here. There's A. And then I have to draw minus B. Remember, minus B is the opposite direction of B. So minus B looks like that. That's minus B. And then the sum of those two vectors, I start at A and draw over in that direction. I drew B a little bit too long, but you can see that D is the right answer. That this vector matches up with this vector. Okay? Do you see that? Y'all follow? Yeah? See it tomorrow. So if you don't see it now, then let me know now. Now's a good time. Okay? Other vector stuff?
So how would you, will we ever need to solve one, A minus B?
Solve one? Where I ask you to do the sum A minus B, like where I do this instead, where I'd have instead of A plus B, I'd do A minus B. I don't think that there are any questions like that on the test. I mean, I just pull your quiz questions directly from the past exams, but if there aren't, I mean, yeah, I could do that on the exam, right? Because those are new questions. You get purely reused questions. So let me just see it. Hold on just a second. I think I have good news. Oh, no. My son's in Quiz Bowl. He's the captain of the Quiz Bowl team, and they're winning. They're winning pretty good. Y'all care? Anybody Quiz Bowl? Quiz Bowl? Yeah. Thibodeau High has a really good Quiz Bowl team. I mean, Edie White has a good Quiz Bowl team, too. Like, they're rivals. They beat them last year. Here. We're going to get them this year. Any Edie White people? Edie White? All right. Okay, can we look at projectile motion? I think that that's sort of the newer topic, and students struggle with that more. Those are completely on the exam 2, so projectile motion is always on exam 2. What's happening here? You'll have about 5 questions from projectile motion. One of your free response for the upcoming exam, a week or 2, will be on projectile motion. Well, your free response will look a lot like this fall 21, FYI, for the upcoming exam. Pretty sure you have one. Oh, no, not like that one. Yeah, Austin? Just checking. Okay. Let's go a little bit older. So remember, you're responsible for fall 17 through fall 21. Okay, let's look at number 2 and 3. This is the fall 18 exam. Numbers 2 and 3. This is a good example of your free response coming up on your exam, but this is just in multiple choice format. But you could have it on your quiz tomorrow too. It has a couple of questions that I asked regarding this single scenario where I have a ball that I kick at an angle of 60 degrees and it goes up and comes back down again. So this is sort of the typical projectile motion. Begin at one level, end at the same level at an angle. I give you the speed of v0 is equal to 32 meters per second, and the angle here is 60 degrees. So the first thing I want to do is to find v0x and v0y. v0x is 32 cosine 60. That's equal to 16 meters per second. And then v0y is equal to 32 sine of 60. And that's equal to 28 meters per second. Yeah. Oh, this is the fall 18. Fall 18. So I always do that first, find the x and y components of those initial velocities. Here, I want to know at the top of the trajectory, what is the speed of the ball? Well, gosh, if you understand projectile motion, that's an easy question because it's going to be what? At the top, the y component of the velocity is 0. So at the top, it's only the x component. So the answer to this would just be 16 meters per second. Okay, but the next one is a little bit more difficult. Consider the previous problem, looking at number 3 here. What is the horizontal range of the ball? So a couple additional steps I need to find. I need to find what is t-top. To find t-top, then I say, well, vy at the top is equal to v0y minus ay t-top. Just like the problem we did on the free response last time for exam 1. This is 0. It stops in the y direction at the top. v0y, I found it over here. That's the y component. Is equal to 28 minus 10 times t-top. That means t-top equals 28 divided by 10, or negative 28 divided by negative 10, or 2.8 seconds. So the top of the trajectory, t is equal to 2.8 seconds. That means down here, t is equal to twice that, or 5.6 seconds. And if I want to know the horizontal range, this is the time that I want. Because at that position, that's what the time is. It's 5.6 seconds. So I would say x is equal to vx times t. That's going to be vx, which I found is 16 meters per second. That's right here. Times t, which is 5.6 seconds. That's 30, 80, 40, 120-ish. 89, 90. Okay, yeah, 90 is the right answer. Okay? 90 meters. You need to know those questions backwards and forwards for the free response. You just need to be able to do them without thinking about them. You just go through, and it's just like, I've done this so many times, I understand. Just a second, today, see it. Right?
Why did you say that on the last question, the 16 meters per second, why would you say that equals the top of the trajectory speed?
At the top of the trajectory, Vy is equal to 0. So that means at the top of the trajectory, the ball only has an x component of the velocity. Okay? But since ax is equal to 0, it doesn't accelerate in the x direction. Whatever my initial velocity is in the x direction, it stays the same. So remember, I drew this graph on the first day when we talked about this. I said that Vx always stays the same. It doesn't change. That's not true for Vy. Vy gets smaller, it goes to 0, and then it gets bigger in the negative direction. Oh, they won 50 to 26. Yay. My daughter's on the Quiz Bowl team too, but she's a freshman, so she didn't get to play today. Does that answer your question, Jadecia? Yes. So she asks, is Vx the same as V naught x? The reason is this. Remember these equations? This is just our kinematics equations. Vx equals V naught x plus Ax times t. However, Ax is equal to 0. So this whole term just goes away. So Vx and V naught x for projectile motion are exactly the same. Are not the same, right? Remember this figure again. Vx stays the same the entire time. Doesn't change. But Vy starts out big, gets smaller, goes to 0, and then gets bigger in the negative direction. It goes up and comes back down again. But in the x direction, it travels at a constant speed. Okay? We saw that with the motion lab when we were throwing the basketball, that the x versus t was a straight line because the acceleration was 0. Okay? There are different types of projectile motion problems. Another type is this one, number 4, where I have a rocket that's fired horizontally off a cliff. So this is some object that follows a path like this. I encourage you to draw a picture. I find it's really helpful. My y displacement is equal to negative 200. Remember we talked about in class how that negative is important, that I'm starting at 0 and I'm going down. That if you don't use the negative, then you're eventually going to wind up with the square root of a negative number, which of course you can't do. So if that happens, just rewind a little bit and you say, oh, I forgot my negative here. So the first thing I want to do is find the time. In order to find the time, all I need to do is ask, how long does this object take to drop 200 meters? I don't need to worry about the x motion. I can just separate those completely and just analyze the y motion. So I can say that y is equal to v naught y times t plus 1/2 ayt squared. This is just one of our two kinematics equations for the y motion, so it has y subscripts. This problem's a little easier because v naught y is equal to 0. The reason it's 0 is because it's fired horizontally. Okay, that means that all the initial velocity is in the x direction. So then I can say minus 200 equals half of negative 10 is minus 5, t squared. So t is the square root of 40, or 6 point something seconds. Okay? What is that? Actually, I'm going to need that. Square root of 40. 6.3 seconds. Okay, so that's how long it takes to get over here. Oh, I didn't even read the question, actually. So this question was asking something different. But let's go ahead and finish this because there are other questions like this. So if t is 6.3 seconds, if I want to know the x range, then I would just say x is equal to vx times t. All right? But actually, this problem, I was just working it without reading it. Y'all don't do that either, okay? Like, make sure you read the problem carefully. Even though you've worked through them probably a bunch of times and you think you know the problem, make sure you read through them. Not like me, okay? Don't be like me. Okay? All right. So in this one, there's a helicopter. Oh, that was like something else. I don't know what that looks like. Anyway, there's a helicopter right there that it hits after 2 seconds. I know that the helicopter isn't on the ground because it takes 6.3 seconds to reach the ground. But after 2 seconds, I want to know what is the velocity or the speed of the rocket when it hits the helicopter. Well, when it hits the helicopter, it's going to have two components to its speed. It's going to have a Vx and it's going to have a Vy. What's Vx? Yeah, so what is it? Well, who said that? What? 45, that's right, Ashley. It's 45 because it started out at 45. It doesn't change. It never changes with our projectile motion problems because there's no forces in the x direction. However, Vy, which I also need to find, is equal to V naught y, which is 0, plus Ay times t. That means it's minus 20 meters per second. Notice V naught y is 0, Ay is negative 10, and t, which was given in the problem, is 2 seconds, so it's minus 20. So I have two vectors, one that's 45, one that is minus 20. I need to now take the resultant of those two vectors. That's the x and the y component of my velocity vector. So I'd say the square root of 45 squared plus 20 squared, just going to leave off that negative, and that gives me whatever the answer is. Probably, let's see. 49. 49 is the answer.
So where'd you get 20 from?
The 20. Okay, yeah. So that's the y component of the velocity when it hits the helicopter right here, which was at a time of 2 seconds. That's the y component of the velocity at 2 seconds. So I calculated it right here. V naught x is 0. Ay is negative 10. T is 2 seconds. And so that's negative 10 times 2 is 20. The negative 10 is our acceleration due to gravity. It's always negative 10. The t is 2. That was given in the problem up here. Okay? All right, what else do you want to work? What types of problems? Well, we haven't done number 5, so let's do number 5. We haven't done this in class either. This is the third type of question. These are not that hard, actually, because you're given the time and you're given all the initial conditions right here, the angle and the speed. So I just want to know, I have this object that shoots up at an angle like this and then goes up and down like that. I want to know how tall is the building. That is, I want to know what is the y displacement. So I know that I'm starting right here at y equals to 0, and I want to know what is y down here. Well, I know the equation for the y motion that describes this. It's equal to v naught y times t plus 1/2 ay t squared. I can find v naught y. V naught y is equal to v naught sine of theta. That's equal to 2.5 sine of 20. I get 0.86. So I can calculate y. I get 0.86 times t, which is 3 seconds. Because the time is given, that's what makes this problem so easy. If you're usually finding the time is the hard part, the time is given here, so it turns out to be a pretty simple problem. And then I get 0.86 times 3 minus, make sure I get that negative in, 5 times 9, I get negative 42 meters. That's the displacement, but I only want to know the height of the building, so I just leave the negative off, because it's not asking for a displacement, it's just how tall is the building. It's 42 meters tall. Okay, we did not work one of those in class. If y'all remind me on Wednesday, I can work through a quick one. So they're not that hard, that's why I didn't really spend any time on it, but I can work through those. I don't know if it's on the quiz or not. It could be on the quiz. All right, what about some of the these other problems? Like a lot of these are from the The concept test we did in class. Number 7's not. Let's just sort of go through these. The following statements is true. Don't y'all like those questions when I say which of the following statements is true? Thank you, Austin. Austin likes them. It's my favorite. It's all right, man. They're good questions. Right, the initial horizontal component of the velocity is equal to the final horizontal component of the velocity. True or not true? That's true. Doesn't change. So the initial is the same as the final, the x component. The acceleration is 0 at the top of the soccer ball's trajectory. No, it's equal to -10. It's always -10. Well, so that's not correct. Not true. Not true. The horizontal component is maximum at the top.
Yes. No, that's the horizontal, no. The horizontal component is maximum when it reaches the ground again.
Be careful. The horizontal component is what? Always the same. It's constant. So the y component is maximum at the beginning and the end, but the horizontal component is always the same. The horizontal component, always the same. Does not change throughout the entire trajectory. So 3 is wrong. And then the horizontal component is equal to the initial vertical component. Could be true, but not necessarily true. So 4 is not right. So 1 only. D is the right answer. When would the initial horizontal component be equal to the initial vertical component? Under what circumstances? Only one circumstance. That's right. Austin, 45-degree angle. Brianna, that's right. It's 45 degrees.
So the horizontal component always constant because it's not accelerating?
That's right, Jadecia. Yeah, so AX is equal to 0. So the horizontal component is always the same. Now, I know what you're thinking. There's some time just before it leaves, right, that it's at rest, and at the end it's at rest. But we're not concerned with those times. We're only concerned with the motion of the object. Okay? AX is equal to 0. That's why it's constant. Yeah. What is the vertical component at the top of the trajectory? You remember that, right? It stops at the top of the trajectory, so Vy is equal to 0 at the top. All right, but now, instead of just having this, we're having this. But this motion still applies, so it stops in the y direction at the top. You see how we're combining these two dimensions of motion, the x and the y dimensions of motion? Okay. Let's see, number 8, we have something like that. Any particular questions y'all want to look at? So you know how to do the graphs. Particular questions? Austin? Like which one? The projectile motion, but what? Number 4?
Yeah.
Like the rocket? Okay, let's go back and look. This is fall 19. Is this significantly different? Now let's go to fall 20. Yeah, let's do fall 20. This was COVID year, wasn't it? So there's no free response on this one. That's why I say it's COVID. We didn't have free response COVID. They did not allow free response during COVID. All right, you kick a soccer ball. Can we do number 1? Is that okay, Austin? So number 1, I want to know the ball's maximum height. Draw a picture. I know that I start with an angle of 30 degrees and an initial speed of 20 meters per second. I can go ahead and figure out what is V naught x, or that would also be, Vx. That's equal to 17 meters per second. How did I get that? What did I do? That's right, y'all. I say 20 times the cosine of 30 for v naught y. That's equal to 10 meters per second. We just write that up here. So v naught x is 20 cosine of 30. V naught y is 20 sine of 30. And then, so now I'm all set up for the problem. I want to know the height. That is, I want to know what is this y displacement. But in order to find that, I'll need to know t top. So I say v in the y direction equals v naught y plus ayt. That's 0 at the top is equal to 10 minus 10 times t. So t is equal to 1 second. Takes 1 second to get up to the top of the trajectory. Now if I want to know y at that point, I say y is equal to v naught y times t plus 1/2 ayt squared. That's going to be v naught y, which is 10 times 1 minus 5 times 1 squared. So it's going to be 5 meters. Okay? Free response, but you'll probably see it on the quiz, something similar to it on the quiz as well, but that will be your free response, so make sure you know how to do that. Quick, 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 without any mistakes, exactly like you know, just rolls off your mind, just like nothing. Okay, we want to do some others of these projectile motion ones. Did I see it? Number 1. Yeah. So first of all, the mass is given. Don't need the mass. Doesn't matter if it's 2 kilograms, 20 kilograms. It doesn't really matter. This one is really similar to the one we just did. The first thing we want to do is find t top. Actually, I'm going to go ahead and calculate my v naught x and my v naught y up here, just because I'm going to need those. So I'll just sort of I get 11 and 19 meters per second. That was 22 cosine of 60, 22 sine of 60. Find t top. I say 0, that's vy at the top, is equal to v naught y, that's 19, minus ay, that's minus 10, times t top. So t top is 1.9 seconds. Okay? I did there, I said vy equals v naught y plus ay times t. And then if I want to know the maximum height, I say y is equal to v naught y, that's 19 times 1.9 minus 5 times 1.9 squared. I get 18 meters. Okay, that's just like the one that we just did. But all these problems are really the same, right? I mean, there's slightly different variations of them, but if you can do one, if you really understand one set of problems, you can do them all. Okay? I don't really require that for the quiz. Like, really, I just want you to spit it back at me. But for the exam coming up, you'll need to know how to do it. Like, you'll need to understand them. The next is, what is the horizontal range? So to find that, I say x is equal to vx times t. But I want to be careful because I'm not going to use 1.9 seconds there. I'm going to use 3.8 seconds there. So I'll have 11 meters per second times 3.8 seconds. The reason I use 3.8 is I took this times 2 and got 3.8 seconds. So the time to come from all the way is twice t top. So 11 times 3.8, that's equal to 42 meters. How long does it take for the ball to come back to ground level? I've already got that. That's 3.8 seconds. And then what is the speed of the ball at 3 seconds? So that's like the helicopter problem that we did before. At t equal 3 seconds, I need to find out what is vy. That's going to be 19 minus 10 times 3, which is what? minus 21, is that, no, 19 minus 30. Negative 11, yeah, thank you, Austin. Yeah, negative 11 meters per second. And then I know what Vx is at that time, right? What is Vx? It's 11 is V naught x. So it's going to be 11. And then I do the square root of 11 squared plus 11 squared. And that's going to be 16. Now that's 4 different problems. You know, that on a multiple choice quiz, it would have, those would be 4 separate questions. Okay? Yeah, did I see? Right here, where I did right here. Yeah, I wanted to know the speed of the object. It asked, what is the speed of the object at t equal 3 seconds? I calculated the y component, and I knew the x component. So I have an x component's like that, my y component's like that. I want to know the magnitude of that velocity, which is there. So it's finding the resultant of those two vectors I'm adding together. When I ask for the speed or the velocity, that I don't say x or y component, then you need to know both the x and the y component, and then take the resultant of the sum, which would be the Pythagorean theorem, the square root of x, a squared plus b squared. Okay? Well, if it's at, yeah, because it's not at the end. I mean, at the end, I know what the speed is, right? What's the speed at the end? Huh? Not 19, no. The total speed of the object at the very end is what? No? 22, right? Because it starts at 22 and it's going to end at 22. But I could also say that at the end, the velocity is the square root of 11 squared plus 19 squared. I mean, that is equal to 22, right? Because those are the x and y components. So if this is my projectile, at the end, I have a velocity that's like that and like that, but they combine to give me a resultant velocity. Okay? See some hesitancy. Well, I think we'll pause there, but if you have additional questions, I can hang around. I think y'all are about ready to head out. But I'm still here, so